Okay, now I'm going to implement a transfer learning model on the previous data that we worked with, and those previous data pertain to the fruit images that we've been working with. And I'm going to work with the ResNet 34 model, and it's a huge model. It's a huge model. I'm not even going to begin to start explaining this one because covering the theory behind this is beyond the scope of this course. And essentially, what you do need to know is that it's one of the most popular models, and as you can see, it has a very complex and an extensive architecture, so it's really very good for classifying real life data. So if you feel the need to use transfer learning model for your own work, then ResNet is a good model and to consider. And I'm going to show you how we can implement this particular model on using Pytorch, using the fruit images that we had been working with throughout. And I have just one disclaimer warning that it takes a very, very long time to run. And in fact, I've been running this code since morning and it's yet to be completed. So if you do decide to go in for the ResNet 34 model or any other transfer learning model, just keep in mind that it could take a very, very long time. And indeed, if you can get your image processing task done using an ordinary convolutional neural network the way we did before, or even a deep neural network, then that is something you should try before jumping into transfer learning. Again, you can import Torch, import NumPy as NP, import Matplot, PyPlot as PLT, the same as before. Now our data training and pre-processing is going to change a slight bit because we are using a transfer learning model. We are going to load the data set and resize the images to 224 size image because the ResNet model needs the images to be 224 to have a size of 224. And indeed, different transfer learning models are going to require images of different input sizes. So again, that's something you can read up in their theory and resize your images accordingly. But I'm just going to show you. And if you recall that we have RGB images, 100 pixels by 100 pixels. So I'm just going to show you how we can resize the images and convert them to tensors to implement the ResNet 34 in a Pytorch environment. And indeed, you can modify it according to the transfer learning model you take. So I create a variable dataset underscore path as before, datasets.image folder. I provide the link to the folder. I call the function transforms from here, .compose. So transforms.resize, I call the function resize 224. So the input images from fruits 360, they are going to be resized to 224, and I'm going to transform them to a tensor. So we put in these images, resize them to 224 as needed by ResNet, and then transform to a tensor. Now we are going to split the data set into 80% training and 20% testing as before, and we end up with 6517 training samples and 1630 testing. We have 15 classes, and that's what we want to classify. And this is our convolutional neural network. And I've just explained why some problems that deep networks have, and that is an issue of a vanishing gradient and where the loss function shrinks to 0 very quickly, and essentially that hampers the learning. So ResNet uses an architecture in CNN and it adds previous information to the upcoming next layer by a new path. And with ResNets, gradients can flow directly through skip connections backwards from the later layers to the initial filters. And since ResNets have different sizes, we can use ResNet 34. And you can read up about this by following this particular link. So we have a 34 layer residual, 7 by 7 convolutional pooling, and this is how it just continues on and on. And for more details, you can read here. We can import a ready-made ResNet model from the Torch Vision library. Import torchvisions.models as models.ResNet34, so it's inbuilt and we just call that. The number of classes that we want to classify is equal to classes num, and this variable has been described previously over here. Classes num, length, training loader, dataset classes, and we have 15 classes, so that's where, so essentially we are trying to classify 15 classes with ResNet34, and this is what the model looks like. So basically we have read that in, and this is the Pytorch implementation of this architecture. It's big. Import torch optim as optim. Again, we are now going to define optimizer and loss function. Import torch nn as nn. Criterion nn cross entropy loss. And we define the optimizer with this particular learning rate. We carry out the model training. Again, we do as before, forward propagation, loss computation, back propagation, loss arrays, epochs. For epoch, and we'll just go with 10 epochs because this takes a very long time. Again, we are going to run the same code as before. We put in our data and target variables in these variables. We set our gradients to 0 before starting. We carry out forward propagation, model underscore out model data. And data, it pertains to the data present in the variable train underscore loader. We carry out loss calculation. Loss dot backward does backward propagation, weight optimization. And as you can see, we are up to 8 epochs, and there has been a sharp decline in the loss. And anyway, when I initially ran it, so this is the training loss. So we will see a sharp decline in training loss. We can carry out the testing as before and check the accuracy of the model, and we get accuracy of 100%. And essentially this is how we can implement a transfer learning model on real life imagery, provided we carry out a basic resizing operation on our image data before.